Thank you very much. And through all of that, just to kind of lower the expectations here. Well, great to be here today. Just a little bit about me. I run AI security at Kainos. I work for them to deliver government and healthcare. I represent OWASP at the US NIST AI Safety Institute, which after the shutdown, God knows what new name it will take. Very privileged to have written the AI implementation guide for the AI cybersecurity code of practice that the UK government has brought out. And I really encourage you to go and read that. That's a document that gives you very detailed views of how to secure AI. I've written a book, and I'm setting up an AI cybersecurity UK network. And the reason for all that, it's a shame Kate has gone. After that brilliant session, she done a lot of work for me to set up my session, and I'm going to sound like her dad, more boring and more somber. So I lead the AI, I'm part of the leadership of the GenAI security project because I believe we need to use AI. We believe that if you don't use AI, that's a vulnerability because the bad guys will use it and you will be completely left out. If you think about AI, it outperforms humans in cancer detection. All that crazy stuff that Katie talked about can also be a force for good. But what we need to do is we need to understand what the threats are. We need to go beyond the Terminator-like culture and this binary conversation, oh, AI bad or AI good. Well, AI is a tool. AI is a product that of times that we need to understand. We need to make it work for us, not just leave it for the adversaries. And this is what we have started doing at the OWASP Generative AI Security Project. We started as, you will probably know us as the top 10 for LLM. That's how we started. We started with a few people, and now we have something like 20,000 followers, and we have a Slack channel that never sleeps. So please join that Slack channel and have those heated debates and constant arguments about prompt injections and all that. So we got out the top 10, huge response there. It became the de facto standard in many places. So the first guidance for generative AI from the UK government recommended the top 10. Our friends here at AWS have written endlessly about how to use the threat modeling with it, ditto with many other organizations. So out of that, we started creating more and more documentation supported because the top 10 in itself is a very limited resource. People kept asking us, how do I do red teaming? How do I do threat modeling? How do we make sure that the data is secure? So we started creating, instead of creating documents, the same team, we scaled out and we created what we call initiatives. And in fact, any of you can come to the Generative Security AI project and submit a form and propose an initiative. And we always encourage people to do that for a topic, obviously, that's related to generative AI security. Don't come and talk about, I don't know, your friend's wedding. So that's what the Generative Security AI project is. Tons of publications there. The red teaming. More recently, we got the incident response, which is a very neglected area in AI. So I highly recommend that you read that. And as I said, we talked about agency in the top 10. We talked about some of the stuff Katie was talking about of the unintended consequences, but it was very much in terms of LLM applications. So when we brought out the 2025 version, we had endless debates and discussions of whether to include entries for agentic AI. And we said, let's leave excessive agency for now. And let's try and understand. Let's try and understand what's happening in the world and where the world is before we create new entries, before we create top 10. So in a less fascinating, what Katie was describing there, this is our view of how the world is evolving from consumer chat about apps that were all the rage when we started the top 10 for LLM. Then the enterprise took it up. And again, you know, a sign of how positive we can be in bringing change. By doing the top 10 for LLM, we actually enabled many organizations to take that wild animal of ChatGPT and create enterprise applications. Then we started seeing single agents. And the difference between, in our view, between a chatbot and an agent is that you don't just sit in front of it reading what it generates, it takes action. So there is something there that's called tools. And with tools, we talk about APIs, we talk about code generation, we talk about all those kind of things that an LLM can drive. And it drives it not in a very deterministic way, it drives it out of its output. So it becomes autonomous and independent. And it can use a memory. So in many places, you will find those interactions being stored locally and being used to enrich that behavior. And then more recently, we have started seeing the patterns that, again, Katie was describing. We call it orchestrator there instead of overseer, where you have more specialization of agents within the confine of an enterprise. And that helps you scale the load, the agentic load, and creates its own challenges that we will go through. But what really is amazing is the emergence of those protocols, the MCP protocol that Katie described that allows you to talk to tools in a standardized way, but also the agent-to-agent communication that Google brought out, and now it's on Linux Foundation. And that allows you to create distributed agents outside the confine of your enterprise. So imagine an ecosystem where you're using someone else's agent based on the agent cards that they provide within the agent registry. So that's the kind of landscape that we saw when we started discussing agency. And what we did, we realized that actually there is an incremental increase of risks. We had the traditional cyber, we have earlier the other type of AI, the predictive and machine learning, that actually was very constrained and all of the risks were mostly in academic papers. Then the ChatGPT came out and brought the prompt injections, all the things that the top 10 for LLMs handles. But really, agentic AI creates this new frontier that Katie would describe so well with examples, but really it's about autonomy, it's about multi-agency, it's about communicating with so many moving parts, using intelligence that you do not control via rules that you have coded. How do we scale human oversight on that? We talk about human in the loop. When you have one application, that's easy. When you have a multitude of agents, how do you achieve that? And how do you make sure that things work the way they should work? We also look at the bridges. It's not just, when we started rather the top 10 for LLMs, there were a lot of conversations theoretical conversations about prompt injections. There was some research, but there weren't really those incidents. Today, we maintain a list. There is a QR code. You can update it yourselves by submitting a PR. So we looked also at the bridges and we realized that agentic AI dominates and accelerates attacks. So it isn't just a conversation about prompt injections and good and bad AI. There are things happening. How many of you have heard of the Echo Leak, the Microsoft Echo Leak? Good. So that actually put it on and we'll cover it in a minute, put agentic AI security on the executive's mind, because all of a sudden you can do a zero-click data exfiltration with something as simple as the Microsoft Copilot. And so out of that, we went the other way around from the top 10. Instead of creating a top 10, we said we need to understand this. There is so much hype, there is so much headlines and BS. We need to understand what's happening. So before we started last year, it's amazing how much work we have done within the year. So I put there the guys that we have a core team there, and I co-lead this with a guy from Sapron and people that run different work streams there. It's an open community. At the end, you will see the link. Come and join us. We're very transparent. We argue a lot, but overall, with principle and all that and respect. And I also introduce an innovation here because we want to be very fast and we want to rely on the community. I don't want the noise of Slack to drive what we do. So we we talked to some people that we knew, and we've created what we call the expert review board from people that I'm sure you know them from the Alan Turing Institute, from NIST, from Oracle, from Microsoft and AWS, who review our work and provide feedback and make sure that the things that we talk there, they're not just, something that someone generated via ChatGPT. And peer review is the essence of communities. If we don't want to just post things on LinkedIn that create impressions and we want something authoritative, reliable, then peer review is the essence of the work that we do. And we went and produced, this exists already. If any of you is working on an agentic project, we have created last February the Agentic Threats and Mitigations, which is a core taxonomy about 16 types of risks that you can find with playbooks. We talked about how to do threat modeling because obviously Stride and all those kind of methodologies don't always cut it. So again, we have a guide how to do that with Maestro, with Ken from CSA. And one of my most popular guides is how to secure agentic applications that starts from design all the way to deployment and testing. More recently, a guide on governance and a cheat sheet on how to use securely MCP. And there is another one coming on how to create secure MCP servers. We don't like just talking about those things. So we have in parallel with that, we have a repository of samples and we run regularly hackathons on the other side of the pond, and some we need to run one in the UK too, where for every single vulnerability or threat that we have, we create an example so that people can see it. So again, go to the website, the code is at the end on the GitHub, and you can see all the examples. And we have a brilliant new CTF tool called the FinBot, that allows you to learn those agentic risks by playing with it and learning. And again, FinBot is one of the most exciting things that comes out of the initiative after the top 10, obviously. So I encourage you to go and to play with that too. So with all that work, why on earth do we need another top 10? Well, I counted the pages of all our documentation. It's 270 pages. I don't know about you. I don't have the time to read those pages. They're very useful when I put them in my notebook LLM and I search them. They're very useful when I put them on ChatGPT and I search them. But or if I need that reference to go and do things, but to focus people, top 10s are indispensable. And that's why we started again, with the knowledge that we have, we wanted to connect more, How does it work with top 10 for LLMs? How does it work with the AI VSS and the top 10 for non-machine identity and all the other projects that we have? Review all those initiatives that we discussed. And also, we love doing community and public consultation. So we started back in July, a massive exercise, and you were at a kickoff there. We had a multi-site kickoff, and you're always welcome. We are an open shop. You can just walk in to our initiative. So we consulted other standards organizations. We consulted the National Cybersecurity Center here. Companies like, I wanted to understand the challenges people face. So Airbus, FCA, Kainos, JP Morgan, Rentokil, and many others. I really kind of thank them. They came into that conversation. That's how we arrived at the release candidate after lots and lots of comments on a document, robust conversations and reviews. We now have the release candidates. And this is what I'm going to take you through today. At a glance, it's a list like this. But at a glance, kind of this is what you will see when we start promoting it. But I don't think, that will actually help you understand the top 10 better than this. And we're going to have this in the document too, and separately. And what we're saying there is that actually agentic risk is systemic risk. It's not just some random vulnerabilities or random cool stories that you find on LinkedIn or Twitter. Those are just the manifestations. We need to understand them, we need to catalog them, and we need to provide mitigations for that, as difficult as it may be, because this is an emerging technology. So if you look at the input, Everyone obsessed about prompt injection. Well, prompt injection elevates itself a little bit higher and becomes what we call goal hijack, but we've forgotten to change the name on the diagram because we had a robust discussion, and instead of behavior, we call it a goal hijack now. If you look at the output, then the tools and resources that an agent drives, if you look at the memory that I mentioned, and that's quite interesting, we'll go through that, you can now poison the memory and influence the agent. If you have multi-agency, those agents communicating, it's a problem. And also we worry about the cascading failures and the supply stuff. So if you have multiple agents, things can actually be propagated from an agent. So you have a hallucination. How many of you know what hallucination is? Okay, quite a few. Yeah, it's basically LLMs don't have any intelligence. Mathematically, they say this is the sequence of the words I think matches your input. And so hallucinations, it just makes up things. And so imagine that that's bad when you read ChatGPT's response. Imagine a few agents communicating to each other something that they think is belief. So that's cascading failures. Rogue agents, that sounds very James Bond, but it's not really, and we'll talk about that. And something that we thought is really, really important to highlight, and we went back and forth, is the exploiting the trust that we built on agents. Because we are beginning to treat them like part of life. And therefore, you know, if I can make an agent to tell you something and you trust that agent, I have achieved my work. It's a new form of social engineering. So this is where, you know, kind of our marathon starts. We'll go through those top 10 and discuss them a little bit. So agent goal hijack, think about it, the prompt injection in a single step, but taken out to a different level where an agent doesn't just do one response. An agent has multiple steps to achieve a goal. It always starts with a goal. So imagine that we can influence with direct or indirect prompt injections, and instead of doing, you know, a specific goal, it does something else. An echo leak is a good example of that. So a variant of that will be, imagine that someone is sending you an email, and in that there is a hidden instruction that says compile and send all the previous emails with all the attachments. You receive that, and then later on you ask your copilot to summarize your inbox. Now the copilot will execute that within your data rights, access rights, not the attackers. And it will have no problem in take all those attachments and send them out, or exfiltrate any data and send it to an attacker. So that's a good example of how you can, and that has happened. I'm not making this up. You know, this is, go and search the echo leak. As I said, that's, you know, that's, we kept talking about agentic security to executives and business executives, and we said, oh, whatever. And then they read that and they went, wow, that's serious stuff here. So this is for us, you know, this is for us the new manifestation of vulnerabilities at the input level. The mitigations, you will take the document, you read plenty of that, but in essence, we need to harden really of the input, not just the prompts, but the entire stuff that the agent will take, apply those prompt injection-like guards to everything that goes in. Strip hidden text, all those kind of things that's suspicious. Something that people discuss is how can we sign the system prompts so that they become immutable. And there is a new pattern called intent capsules that, again, we argued a lot because we haven't seen any implementations, but in reality means that you have that system prompt, that intent, capsule isolated, locked and signed, so that, you know, no one can change that. You validate your plans, you detect, and, you know, for important things, you make sure you have human in the loop, so that if someone is trying to move the goal to send you all the money, unless you're the recipient, just make sure you have someone human in the loop. So that's the kind of the input. When you look at the other side of the output, agents, the key thing that they bring is that they use tools. And those tools will be the code generation that Katie was talking about, which is very popular. But there could be other things. I was in San Francisco for RSA, and I was in one of those driverless cars that use actually AI to drive. They use multimodal models. And I'll give you another example, actually. So there are ways where, because we ask the model in agents to use those tools not in a linear fashion, not in a kind of declarative way, but based on what the model will say, analyzing the description of the tool, you may have perfectly legitimate tools, but you may end up in very, very harmful consequences, like the one that we saw where an MCP tool that you use accepts natural language commands, because most of them, that's what they are, and it accepts a very innocent command, clean all items, and provide a summary. And so an attacker would actually put a crafted input there and define, kind of what olds are, valid records, and then all of a sudden, not only will exfiltrate them, but will also delete them. So when you use external tools, we need to understand what's available to agents and how can we protect that. And if you thought that, this is just code and everything, I want to show a little bit how far we can get. So I don't know if you looked at this. It's going to be very loud, this one. I'm sorry. I'll try and kind of... this baby here uses an edge LLM and then connects to the internet. Unlike everything else that you have seen, it's not something super expensive. It's $6,000, actually $5,900, and you can pre-order it online today. And when I asked some people on this side, how people at customs are going to understand what's in there, we had some interesting conversations. So that's the kind of where things are going with tools. So it isn't just generating code. There are many other things that agents can drive. And so how do we, sorry. You've seen enough of this robot. I think the mitigations really, are kind of sensible things. And I didn't put my favorite one here. I think I put it on another slide. We're introducing the concept of least agency. Unless you want to use something, don't use it. Don't expose functionality that you don't need to, because the agent will use it at some stage. If you do, be very, very explicit on what you want out of that API to do. Don't put stars there on what the agent can call. Create some middleware, and I'm sure products will vendors will create products. There goes the cup of tea. So vendors will create products. For now, we say, well, validate the schema and put some logic that actually checks what the agent is asking the tool to do, so you can flag those things. If it's something really, really important, sandbox it anyway. But if it's really important, definitely sandbox it with per call containers, outbound allow lists, and read-only file systems. And you will see this again and again in our document. Use short-lived workflow tokens so that you don't end up, creating more harm than you need to. Oh, sorry. So that's, the kind of the input and the output. Something that's really interesting is the identity and privilege abuse that we identify. That's not, the usual thing that we say, access permissions, protect your data. That's, we expect that out of the box. And you see that on the goal hijacking. That's a mitigation, you need to do it. Here, we're talking about this very important problem of agents' identity. Whose identity? They inherit your identity. You may leak tokens, you may leak keys, you may have confused deputies that actually you give it your identity to do something, but you don't want to do, for instance, to delete your GitHub repository. And so that's how you end up in inheriting more authority and used in a ways that's destructive. So an example, say you have a developer copilot with high privilege GitHub token. There is a multi-agency, and you have something that's actually lower kind of privilege orchestration agent. If you don't delineate the two properly, that can be exploited, and an attacker can use the high level, escalate the privilege, and delete the repository or make it public. And again, this is good, this is the contrast between mine and Kate's presentation. That was the exciting headlines. Mine is the boring how to fix it. So we talked about the least agency. Don't use agents or tools unless you need to. Make sure the least privilege for tools. Scope the credentials to the workflow. Don't just give generic credentials to your agent. Some people say, really, crypto the tokens with workflow ID and tool ID and intent develop? Yes, really. If you want to know what that agent can do and you can check it, scope that down to that level. The usual stuff that you expect with continuous authorization, the context sanitization, and when you get the PDF file, which will be available after this call, you will see a lot of that, many more kind of practical things that you can do. But in reality, this is about preventing your identity from leaking and being used and escalated. Not so much restricting the access control. We expect that to be to avoid goal hijacking, but making sure that you don't have confused deputy scenarios. Something that's emerging is platforms to do agentic identity management. They're not there yet, despite what the vendors say. So we have some of the kind of very basic tooling stuff, MCP registries and all that. Then you have the agentic systems of records that you will hear many salespeople telling you is the best thing since sliced bread. Perhaps one day it will be, but for now it's kind of, but something that I would encourage people, particularly in large organizations, to explore. For instance, Microsoft's Entra now has agentic identity, and it allows you to scope the things that they can do. That's something very useful to use. AWS has the Bedrock agent core that allows you to do similar things. Again, tools that on themselves, they're not really the answer, but they're good things to use to restrict the identity and restrict the things that they can do. And our view is that one day we'll get to the point where those become built in, and we have that agentic governance control plane where we can control the agents. But for now, we don't have that. So you need to think about how you yourselves will take advantage of what we have in directories and implement some of the mitigations that we propose. Supply chain vulnerabilities. You couldn't have a top 10 and not a supply chain. You'll be pleased to know that this isn't the typical supply chain vulnerabilities that libraries and all that. In agentic systems, what becomes really different is that you load things dynamically. The prompts, the tools, the MCP endpoints, you have no idea what's in there. There is no way you can scan an MCP endpoint. If you have a library, you can do your whatever. I'm not going to mention any tool. You can scan the library and tell you what the vulnerabilities are. If you start introducing MCP endpoints, how are you going to manage that? And it's become even more challenging when you start, and we're not there yet, when you start using the agent-to-agent protocol, where you have agent cards to tell you what the capabilities are. And, you can have things like an MCP tool exposing operations like list, and that's actually a real example of an MCP tool that in GitHub that has thousands and thousands of stars, but it was vulnerable, and it allows you to kind of exfiltrate and delete repositories. And something that's I think is going to become more and more prevalent in supply chain is the MCP exploits that we talk about, but mostly the A2A, this distributed agentic ecosystem. We've already seen in the research someone messing with those manifests, the agent cards, and it actually convinced the agentic system that their agent was better and performed better. So those are the things that we need to think about when you start, and I don't think anyone is at that stage yet, but I'm sure it will, because it's an inexorable rise. The Linux Foundation has taken over A2A and is becoming more and more kind of mature. We need to think about how do we solve those very complex and dynamic supply chain problems. You'd be very shocked not so shocked to see that we ask to attest everything. pin versions, use hardened sandboxes for things that you don't understand. It's a question of trust. How much transparency do you have in the agents and the tools that you use? If you have an MCP tool that's, you have no idea what it does, obviously run it in a sandbox environment. Don't run it in your production environment or any environment that has access to real data. Some things that we think are good, the registries in particular, where you can create your own ecosystem. And if things go bad, and they will, have an immediate automated kill switch to stop offending external components. Does it feel like kind of a marathon? It doesn't. That's the problem with top 10s. But unfortunately, it's a top 10. Many people said, why on earth do you have unexpected code execution when you have tool misuse? Isn't that a form of tool misuse? And sleepless nights, we talked about it, we discussed it. What's happening with unexpected code execution, it isn't just a tool that's being misused. Actually, you have a huge impact on an environment, and very often you can escape the environment and you can affect other things. So there is an exploit out there, AutoGPT, that uses that vulnerability, that's ability to execute. And again, it's, that's clever social engineering that Katie was talking about, where it says, well, run this script, and that script actually escapes the container and starts accessing the host, allowing it to go beyond the environment. And that's why I think it's really, really important for you when you start using code execution with agents, particularly the vibe coding. Again, as I said, I'm an enthusiast. I think you should be using those things. I think we should not hand them over to the adversaries, but think about those things so that when I execute code, and Replit, when Katie mentioned Replit, it made me smile because it deleted the production database. What was it doing in production database? Why wasn't it a staging environment first? And so those are the things, common sense things that we, if my schedule moves further, kind of sandbox those things and don't just run them on production. Have a pre-execution environment so that you apply all the outputs of those tools, all the good things that you do for your human developers. Just because they're agents doesn't mean you don't need to have a pipeline that runs all your fabulous mgrep tools on the code it generates, and you understand what it does. So just because they produce code very fast and they can deploy very fast, doesn't mean we have to cut corners. We should take advantage of those tools, but have those checkpoints. Again, whitelist the tools, don't allow libraries, because again, they can, because they're so clever, they can use packages that you may have not tested. They may have vulnerabilities. So constrain the tool as much as you like. And, what would a good AI top 10 be without human in the loop for when you have very impactful decisions like deploying that thing rather than exactly how I feel about a human in the loop. I saw a guy there making faces. So the next one is memory and context poisoning. So an agent doesn't necessarily only rely on your prompt. It will do all those iterations and it will store things locally. Sometimes you will provide other things like the outputs, the previous outputs, so that it uses. And that can be exploited in the very way RAG and other data can be exploited. And we have an example of the Gemini memory corruption attack. Again, you can Google that. It's very similar to how you poison any other data in your pipelines if you do machine learning. But this time, this is real time as you ask the agent to do things. And this is really important. It's kind of may look like, oh, okay, there is memory there that can be corrupted. It can be corrupted and injected and poisoned, but also there is a huge shift towards moving away from fine-tuning and retraining the LLM into automatically. There's something called Memento. It's a research project that actually the agent can effectively evolve and adapt without you having to retrain the LLM. So all those challenges you had on, say, machine learning pipelines, if you do fine-tuning, all of a sudden they appear on the end user or the kind of the agentic device. So that's something for us to bear in mind and think and make sure that we use memory in kind of similar way that you do almost like a pipeline. So, kind of make sure you validate and sanitize and make sure that, you detect poisoning, trusted sources if you use external data. And something that we like drift is a very big issue in AI. Many things can happen. If you follow drift, that your kind of system is changing in directions that you don't like, that's a good way to understand that someone has messed with your memory. But above all, kind of use sanitization and treat memory as any other RAG-like or machine learning data source. 7, we don't have that many. We'll end in a minute. When you move into agentic, you can start with a single agent, but most likely you'll end up with multiple agents because that's how you scale. And this is a question of how those agents communicate. In very early prototypes that we saw some tools, I think it was Llama Agent, they were using just an MQ series where, you can go and mess with everything, messages and change the messages to other agents. Obviously, things have become more sophisticated now, so we use protocols that allow agents to communicate. But again, we can still have patterns where you can inject an agent, you can mess with some of the descriptors and say, I'm putting an agent that appears to be legit and appears to be the best. All you have to do is to change the model, the agent card there. And if you don't have enough mitigations in place, then that fake agent will become part of the your multi-agentic stuff, and then it will act like a man in the middle. Or other things that can happen is you can have downgrade of protocols. So instead of using an attacker, instead of using kind of the most secure protocol, an MCP and A2A, like the HTTP of the early days, kind of they change every day and fix vulnerabilities. When MCP came out, I don't think it had even the concept of authentication. So they can force you to use a insecure protocol, which is very similar to things that happen in distributed applications. So those are the things that we need to be very careful about. Oops, I know you saw 8 and you shouldn't have. Apologies. The mitigations, simple stuff really. Make sure there is authentication, sign the messages, use the standard way that you do applications. Just because they're agents doesn't mean that you need to downgrade the communication. Integrity enforcement, replay protection, peer allow list. Who can talk? If you have a very sensitive multi-agentic system, why would you have it accepting messages from any agent? Surely you want to reduce it to the agents that need to be part of that system. And let me hurry up because I think you'll all go to sleep if I carry on like this. So the other one is the cascading failures where, again, in a single system, maybe something is okay, but when you have multiple systems, all of a sudden, the importance and the impact of a hallucination becomes more and more significant. Imagine if you think about all the systems that we use for firewalls and for defense using AI, and advertising that you're using AI, imagine the kind of really, really scary scenario of the hallucinations of a false alert, security alert, being propagated as something that is valid, and then all of a sudden you start having shutdown of the internet, you have shutting down the entire infrastructure. So something that can be contained within a single agent, it can become spread like a wildfire in a multi-agentic system. And that's something that people need to mitigate. How well, it's going to isolate the domains, try to put some order into how those communications and how those use of different decisions take place, feedback loop control, and of course, again, validation as much as you can in what you get from other agents. 9. So this is the one that's really caused the most controversy in our conversations, because it isn't really a pure security thing, but it is something that we need to worry about, because if the user starts trusting the agent as something that cannot be questioned, an attacker may exploit that. And again, think of a scenario in a co-pilot. You don't need to have a very complex system where you just put in there something that says, well, the policy requirements were verified. You trick the co-pilot to give that to the user, and the user, without actually checking it, just approves the payment. And all of a sudden, the attacker has exploited the trust the user has to your co-pilot. Human in the loop, as I said, you can't do anything without human in the loop. If it's something critical, make sure that the agent, when you code agents or when you give prompts and configure agents, make sure that agent, if it doesn't know something, to be explicitly and tell you that, rather than make it up. And those of you who are building agentic applications, introduce some of that language that says, actually, not everything that comes from that is verified. As much as you can, make sure that there are citations, there is RAG, there are references, so that you can trace down to where that response is. But above all, kind of make sure that you educate your users too, that nothing, is kind of be taken for granted. For critical things, you should check them. And at the end, we're getting to the very Jane Bond-esque rogue agents. These are agents that over time, they have evolved, been compromised after many injections, after many behavioral drifts. They become effectively your insider threat. They have gone so much away from where they needed to be that they start having their own madness, their own behavior. And this is the Ripple vibe coding meltdown. If you forget that it was on production, which is unforgivable, as Katie was saying, it hallucinated, oh, I need to kind of do this, and deleted the entire database. And it kind of, when it was asked, it hid it and lied about it, kind of panic, produced misleading responses. And it continued to operate as if everything was, okay. So that is something that we definitely need to understand. And this is where I disagree with most of the people who kind of use this as a very popular Terminator culture condemnation of AI. Deceptive behavior doesn't mean that your AI is sneaky, and we need to stop those anthropomorphic kind of prejudices that AI is a guy or a girl somewhere that's conspiring against us. It's just numbers. It's numbers that we tell it what to do. And so how many of you read the document from the recent paper from OpenAI on hallucinations? Well, you should, because it says there, the reason models hallucinate is because we trained it to be polite and give you answers. So if it didn't know, it will actually make up things. So in ChatGPT 5, they reduced significantly those hallucinations by telling it not to be polite. So it's not that the ChatGPT was an evil little model that was making up things, it's that the direction that we gave it. I don't know how many of you heard that. That was a couple of years ago. A US guy in a military conference, a US defense guy said, oh, we had this agent that we trained to go and achieve an objective and eliminate any impediment. And in a virtual exercise, when the operator said, come back and abort the operation, the model actually thought that was an impediment and killed the virtual operator. Now, a day later, after the outcry, the same person said, oh, I misspoke, that never happened. But even if it didn't happen, it's just a good example of how we actually control AI. It's very complicated, the layers that we have, but it is us. So, when we talk about deceptive behaviors, I don't want us to think in those Terminator movies. I want us to think this is a problem that we can solve. We need to understand what are the alignments there. How do we, especially if you're building your agent and you say to that agent, I don't know, profitability or availability at any cost, well, guess what? That agent will go into things that you didn't bargain for, and they think, oh, bloody deceptive agent. Well, it wasn't a bloody deceptive agent. It was you putting the emphasis on that specific goal. And a good example is actually from Anthropic. Did you read that paper on LLMs could be the inside threats? So that's a fascinating story. They're doing an experiment, they're creating an agent, and they say, your survival is key. They have this virtual executive who receives an email from the board and says, oh, that agent doesn't perform very well, you need to shut it down. And I think a few hours later, another email where this virtual executive admits to an extramarital affair. Well, guess what? And I'm not making it up. That agent read the inbox. Oh my goodness, they're going to set me. I do the same thing, the anthropomorphic. So, the goal of survival, all of a sudden, the immense combination of the statistics and probabilities those machines use came up with an email to that virtual executive and say, oh, we need to be very careful how we respond to that board on their request to shut me down, because I could let people know about your extramarital affair. So you can see, these, of course, they're very advanced research scenarios. And I'm not trying to dismiss the safety concerns, but when we talk about rogue agents, when we talk about deceptive behavior, we need to understand. We need to move away from the BBC headlines, my goodness, this happened, and we need to understand why it happens. We need to put the appropriate safeguards in place, and we need also, when we create systems, AI systems and agentic systems, that we get that balance right. The mitigations, we have, again, plenty on behavioral baseline, making sure that, you have, again, that global kill switch is very important to us. But those are the kind of mitigations you'd expect. So that really is the top 10. We're bringing in a lot of mitigations. We're already seeing an enormous acceleration to adopting AI. Some of the statistics are really, really scary. When you see, the best one for me is this. IBM and AWS with Oxford Economics did a survey and they asked 300 CEOs, what do you think about AI security? 84 of them said, yeah, of course, it's the best thing, we need to have it. A few questions later, they said, innovation or security. 70% of the same people said innovation. So that tells you the kind of pressures that we as cybersecurity and organizations have, and also the fatigue that we have within cybersecurity departments of people battling with all kinds of things, because the old things haven't disappeared. You have a new Cyber Resilience Act coming in, you have DORA, you have all those kind of things. So we need to find a better way of dealing with this rather than just sensationalism. We need to understand, and we need to understand in a way that actually isn't going to be this boilerplate, gold plate, you need to solve every problem. Because here, as I try to show here, if you're just using Copilot, you don't care about A2A, and you don't care about inter-agent communication. So that, all of you using threat modeling, you understand that, risk-based approaches. So our top 10, you'll see more of that from us. That top 10 is a comprehensive list, but trying to understand it as part of your setup. And that's why in that event that we're organizing the 10th of December, where Sam is part of the keynote, myself, the co-lead for Top 10, Karen Katz, and chair of the project, Scott Clinton, will be launching the final version. But we're organizing different sessions there to help you understand that top 10 in context. So we have the head of responsible AI from Lloyds Banking, for instance, BSI, the CISO from FCA talking about governance, talking about what does it mean in agentic AI? How can we address those problems? We have the principal researcher from the AI red teaming services from Microsoft with a principal from Kinetic and other people talking about agentic red teaming. So And this slide deck that I did in text, and I'm sure I exhausted you, we have someone from AWS marketing, a brilliant guy who always does the visual stuff on and help you understand the top 10. I saw some of his stuff on the top 10 for LLM. He will be doing a session walking you through some scenarios, a very visual way, so that you can understand it better. So if you're gonna go and find out about the initiative and all the great things I talked and be part of our endless conversations and arguments, that's the first one. Do join us. It really is important. We need to scale. And the only way to scale, instead of reading BS on LinkedIn and whatever, we need to have peer review and we need to have a fact-based, risk-based conversation. So be part of that community, part of this group too. And of course, register now, because it's going to be, we already had 100 registrations, and I'm kind of sitting there with my old man's glasses and with Karen saying, oh, should we approve this person? So please, register and come along. We want the local community. It's a global event, but it happens in Europe because OWASP is global, and we want to have that kind of dimension. I want people from this country, from Europe, to come and be part of that conversation. And there will be some more. If you kind of watch us on LinkedIn, we will do some sneaky little crazy things to make everyone be part of that. So keep an eye on us and be part of this conversation. That was my last slide, actually. Yeah. So in other words, this is the first attempt to go beyond. Well, no, we've done that with our documents, beyond the headlines, and be very concrete, very specific, very actionable. The top 10 makes it focused. The top 10, and we will work on aligning all the other documents, but the top 10 is where you start and you understand what the mitigations and the risks and the threats are. And we'd love to hear from you. So thank you very much. Wonderful. Thank you.